Okay, let's do another example using the cylindrical shell method. So again, let me read to you the setup. I just wrote down the information. So it says define R as the region bounded above by the graph of f of x equal to 2x minus 2 and below by the x-axis over the interval from 0 to 2. Find the volume of the solid of revolution formed by revolving R around the y-axis. Okay, so again, we're going to do the cylindrical shell method. Okay, and now, again, if you sketch this thing, okay, so again, if we sketch this thing, we get something that looks like that. So it goes from 0 to 2, right? So this is 0 to 2. And so this is the region that we're going to, again, rotate around the y-axis. Okay, again, so it gives you an idea. Again, if you want to draw your rectangle. Okay, so again, because we're going, our rectangle is going this way, right? We're going to go use the cylindrical shell method. So I'm going to set it up. So we're going to go volume equals the integral from 0 to 2. And it's going to be 2 pi. And then it's going to be x. So that's always going to be the same. And then f of x. Well, what's f of x? F of x is 2x minus x squared dx. Okay? So I've got the setup already done. So now I'm just going to simplify and then integrate. So let's simplify this thing. Let's do it this way, just in case I run out of room. So again, what can I do here? I can factor out, let me see, how do I want to do that? In this case, I'm going to distribute the x and then just do it term by term. So it's going to be 2 pi, the integral from 0 to 3, and this is going to be 2x squared minus x cubed dx. There you go. Okay, now I can just integrate it term by term. And so my volume turns out to be 2 pi times 2/3 x cubed minus 1/4 x to the 4th evaluated from 0 to 3. And of course, since I've got x's in both terms, it's just going to be 0. So I can ignore this part and just evaluate it at 3 and be done. So this is going to be 2 pi times 2/3 3 to the 3rd minus 1/4 3 to the 4th. Okay, and so now if I simplify this, well, if I simplify this, I get 9 times 2, because this 3 is going to cancel with one of these. So I'm going to get 2 pi times what? 2 times 9, which is 18, minus, well, this is going to be 81 over 4. Right? And so if I simplify this thing, what do you get? Well, I'm going to put this over 4, so that's going to be what? 72. So 72 over 4. Ooh, hold on a second. Did I do that right? Should not get a negative number. Did I do that right? Yeah, that's right. So let me see here. Just want to make sure. So I got 2 pi. So that's going to be 27 divided by 3, which is 9. 9 times 2 is 18. And then this is going to be 81 over 4. Right? Oh, I'm sorry. Now I see my mistake. No wonder it didn't work. This is 2. See, I had 2 here, and then I changed it to 3 here for some reason. See again, I make mistakes too. So, see, that's another thing. So what happened was here, I'm going to get 72 over 4. Well, if I take 72 minus 81, that gives me a negative number. I cannot have negative area or volume. So I knew I made a mistake somewhere, so I had to go back. So then I realized, I accidentally made it a 3 here. So this should be 2, and these should be then 2. That will make a big difference. Okay, so that means, what am I going to get? This is going to be 8, 16. So this is going to be 16 thirds minus 16 fourths. There we go. And so if we simplify that, we get 8 pi over 3. Oops, almost did it again. Or 2 2/3 pi. Either way, I'm fine with. Okay, so that wraps up that example. If you have any questions, let me know. But here's one for you to do on your own. I'll always give you one for practice, or at least try to. And so, here you go. So it says, define R as the region bounded above by the graph of f of x equal to 3x minus x squared, and below by the x-axis, of course, at this point, and then over the interval from 0 to 2 again, and of course we're going to go around the y-axis. So what they want you to do is, again, find the volume of the solid of revolution formed by revolving R around the y-axis. And so R is bounded by these. Okay. Again, as usual, if you get stuck or if you want confirmation, let me know. Email me. Have a great day.